and I'm excited to have all of you here for our AI Study Jams journey. This is a community-driven program designed exactly to help beginners get started with artificial intelligence. So, whether you are completely new or looking to reinforce your understanding, you're in the right place. Let's learn and grow together. My name is Anna. I'm Google Developer Group Ahlen organizer. But before we start, I'd like to mention that it's a very friendly and inclusive space. So let's encourage each other and lift one another up. Negative jokes, comments, or behaviors that put others down have no place here. Please maintain a professional and friendly attitude. We are here to make sure everyone feels comfortable and included. This event session will be recorded and after share it. So, first of all, let's a little summarize AI. What is exactly AI Study Jams about? So, AI Study Jams is a learning opportunity leveraging accessible learning resources such as Kaggle Learn, books, and free online courses. And we will share all these links during our 4-week journey. And of course, it includes hands-on assessment, tutorials, and tech talks as today, and group discussions. So feel free to share your questions at our Discord channel, which I share at the end of this session. This is a great opportunity to bring members of this community together, I hope, so that we started with artificial intelligence. So, this is our the first week, and it's all about setting the foundation. So, this session, Kate will introduce machine learning, pandas, and if you haven't coding experience, it's not a big problem. I'll share with you this link, Intro to Programming course. Feel free to finish this course if you haven't this skills. And of course, after finishing any course at Kaggle, you get amazing certificate which you can after share it your social media, for example, LinkedIn. So not only get new skills, but get certificates. So, and let's take a look at what's ahead in our artificial intelligence study Jams journey. Our first week is about intro to machine learning and pandas. So we start with the fundamentals, understand what machine learning is and how it works, and also explore pandas, a key Python library for handling and analyzing data. Our next week number 2, is about intermediate machine learning and feature engineering. So we will go deeper into feature engineering, which is a crucial step in machine learning where we transform raw data into meaningful inputs that improve model performance. Our week number 3 will be about intro to deep learning and computer vision. So exciting topics. We will explore deep learning, the technology behind AI breakthroughs in speech and image recognition. And we also will introduce computer vision, which allows machines to see and process visual information. And our last week number 4, will be about time series and introduction to artificial intelligence ethics, crucial topics. So we will focus on time series forecasting, which is a key technique for predicting future trends in fields like finance, healthcare, and sales. And of course, we will discuss AI ethics, ensuring we develop responsible and fair AI solutions. So every Saturday we will have short online events with introduction necessary materials. We will step by step go through necessary courses. And of course, each week I'll introduce our speaker will introduce homework. It's a list of required courses which you need to finish during the next week and before the next online session. So let's start. I stop sharing. So Kate, please share your screen.
Just a moment.
Meanwhile, I'll share our Discord channel. I prepared exactly for this study.
So today we are starting from the basics. So no pre-experience is required. The session is completely beginner friendly. My name is Kate. I'm Women Tech Makers Ambassador. I'm also machine learning professional certified. I'm engineer. Nice to meet you all. First of all, we cover some key machine learning concept, what machine learning is, how it works, where it's used in real life, and then we will walk through a step-by-step guide to the Kaggle Intro Machine Learning and Pandas courses. It will help you build practical skills at your own pace. This session is about getting hands-on, exploring machine learning fundamentals, preparing you for more advanced topics in the coming weeks. Let's dive in. First of all, we explore Introduction to Machine Learning course on Kaggle. This course provides a great overview of the fundamental concepts, from what machine learning is to how train and evaluate basic models. We will learn about different types of models, the concept of training data, evaluation metrics. The hands-on exercises on Kaggle really helped solidify those concepts and gave us a first taste of working with real data. This Kaggle website is very important. It contains different courses on machine learning, so feel free to Google it and study different courses. They also do some competitions. When you will be more experienced, you can participate in competitions also. It's a very great resource. Equally important will be our work with Pandas Kaggle course. Pandas is absolutely essential for any machine learning practitioner, and this course gave us fantastic introduction on its capabilities. We will learn how to use data frames, which are like tables of data, and series, which are like single columns from a table. We will explore how to perform essential data manipulation tasks like cleaning and transforming data, and how to do some initial analysis. The practical exercises on Kaggle are key to becoming familiar with Pandas library. By completing the Intro to ML and Pandas courses, you will get a solid foundation to build upon. We will experience working with real data in a structured environment, which is crucial for moving forward. Let's start. This course provides a great overview of the fundamental concepts. How the first lesson, how models work. It introduces the idea of machine learning models and focused on simple but important model called decision tree. We will start with simple decision tree model, which serves as the foundation for more advanced models. Decision trees are like flow charts. They make decisions by asking a series of questions about the data. Each question corresponds to a feature of data, and the tree branches based on the answers to those questions. Eventually, the tree leads to a prediction. The key is how the decision tree learns which question to ask and where to branch. The model learns these rules from the training data. It looks for the features that are most predictive of the target variable. The things that we are trying to predict, like house price. It tries to find the questions that best split the data into groups that are singular as possible with respect to the target variable. This process repeated recursively, creating the branches of the tree. While decision trees are relatively simple, they are also incredibly important because they serve as a foundation for more advanced models. Many other powerful machine learning algorithms, like random forests and gradient boosters, are actually built upon the principles of decision trees. So, understanding how decision trees work is a crucial first step in your machine learning journey. This lesson provides a great introduction. This lesson provides a great introduction to the core idea of machine learning models, learning patterns from data to make predictions. Understanding how decision trees work gives us a concrete example of how this learning process happens. Continuing our journey through the Intro to ML Kaggle course, we're now focusing on a crucial step before we even start building models: basic data exploration. This lesson emphasizes why it's so important to understand our data before we jump into modeling. Before building a model, we need to explore our dataset. We use Pandas in Python to load the dataset and inspect key statistics. This helps us understand our data and detect any missing values. Checking for missing values is crucial because they can affect model performance. The first thing we need to do is load our data into format that we can work with. Like we learned in Pandas course, we use the Pandas library in that Python to load datasets. Specifically, we'll open the file pd read CSV to load data from CSV files, which are common format for machine learning datasets. This step brings our data into Pandas data frame, making it easy to inspect and analyze. Once our data is in a data frame, we want to get a sense of its overall characteristics. We use Pandas functions like describe to generate descriptive statistics. This gives us information like the mean, median, standard deviation, minimum, and maximum values for each numeric column. This statistics gives us a quick overview of the distribution and range of our data, helping us to identify potential outliers and unusual patterns. Basic data exploration is absolutely essential before building any machine learning model. Understanding our data helps us to identify potential problems, choose appropriate models, and make informed decisions about data preprocessing. A critical part of data exploration is checking for missing values. Real-world datasets often have missing data, and these gaps can affect the performance of our machine learning models. We learn how to use functions like oh, sorry, it's my Gemini started to work unexpectedly. Sorry. We learn how to use functions like is now to identify missing values in our data frame. This allows us to see which columns have missing data and how much missing data there is. Why is checking for missing values so important? Because many machine learning algorithms can't handle missing data directly. We'll need to decide how to deal with these missing values, whether we fill them in or remove the rows or columns that contain them. Understanding the extent and patterns of missing data is crucial for making informed decisions about how to handle them. Basic data exploration is absolutely essential before building any machine learning model. Understanding our data helps us to identify potential problems, choose appropriate models, and make informed decisions about data preprocessing. This lesson, your first ML model, walks us through the process of defining the problem, selecting the data, training a model, and making predictions. We will use the decision tree model, which we already learned how it works. We built our first ML model and defined the target variable, something that we want to predict, and select features, the input variables. Using scikit-learn, we train a decision tree model to learn from the data and make decisions. Every machine learning task starts with defining. You can ask questions here or in Discord, it doesn't matter. We will answer you. Every machine learning task starts with defining what we want to predict. This is called target variable. It's the output we want our model to generate. For example, if we predicting house prices, the target variable is the price. If we classify images, the target variable is the category of the image. Identifying the correct target variable is crucial because it determines what our model is trying to learn. Then we need to select the features. These are the input variables that our model will use to make predictions. They are the information we give to the model to learn from. In our house price example, features might include the size of the house, number of bedrooms, the location. Choosing from right features is essential for building a good model. We want to select features that are relevant to the target variable and that provide enough information for the model to learn effectively. In this lesson, we will focus on training a decision tree model. We use scikit-learn library in Python, a powerful tool for machine learning to train our first model. We feed our selected features and the target variable to the model, and the model learns the relationships between them. This is the training process. The model learns the patterns in the data so it can make predictions on the new data. Once our model is trained, we can use it to make predictions on new unseen data. This lesson provides a complete walkthrough of building a basic machine learning model, from defining the target and selecting features to training the model and making predictions. Now that we know how to build a basic ML model, the next crucial question is, how do we know if our model is any good? This lesson, Model Validation, addresses this very important question. It's not enough just to train a model. We need to evaluate its performance reliable. We need to know if predictions of this model works correctly. A common mistake that beginners make is evaluating the model's performance only on the data it was trained on. This can lead to overly optimistic and misleading results. Why? Because the model has seen the data. It's like giving a student the answer key before the test. They'll do great on the test, but that doesn't mean that they actually learn the material. Our model might perform perfectly on the training data, but fail on the new unseen data. The solution to the problem is to split data into two separate sets, a training set and a testing set. We train our model on the training set and then we evaluate its performance on the testing set. The testing set is the data that the model has never seen before. This gives us much more realistic estimate on how well our model will perform on new real-world data. So we will separate our data into training set and testing set. By evaluating our model on testing set, we can measure its accuracy on unseen data. This gives us a much more reliable measure of how well our model is doing. We can use various metrics to quantify the model's performance on the testing set. This helps us to compare different models and choose the best one for our task. Model validation is absolutely essential in machine learning. Without proper validation, we can't trust our model predictions. The train test split is a fundamental technique for ensuring that our models are robust and generalize well on new data. It prevents us from being fooled by overly optimistic results on the training data. This lesson on defeating and overfitting explores two common problems that can arise when training machine learning models: underfitting and overfitting. Finding the sweet spot between these two extremes is a crucial for building effective models. A simple model may not capture uh, important details, it's underfitting, while a complex model may memorize the training data and fail on the new data. It's overfitting. The goal was to find the right balance so our model generalizes well on new data. When building models, we face a trade off. A simple model might underfit, it fails to capture important patterns and performs poorly even on the training data. Think of it like trying to predict house prices using only the size of the house, ignoring location or number of bedrooms. On the other hand, a complex model might overfit. It memorizes the training data, including noise, and performs great on training data but poorly on new data. It's like memorizing practice questions but failing the real test. Our goal is to find the sweet spot, a model that's complex enough to learn the real patterns, but not so complex that it memorizes noise. Our goal is to find the right balance between underfitting and overfitting. We want a model that is complex enough to capture the important patterns in the data, but not so complex that it memorizes the noise. This balance is what we call generalization, the ability of the model to perform well on new unseen data. A model that generalizes well on one that performs well on both the training and testing sets, although usually slightly better on the training set. The key is to find that sweet spot. One way to control this complexity is by adjusting the tree's depth using max leaf nodes. A shallow tree has few splits, which can lead to underfitting. A deep tree with many splits can lead to overfitting. The max leaf nodes parameter limits the number of leaves or final decision points in the tree. Fewer leaves means a simpler tree, while more leaves means a complex tree. We want to find the optimal number of leaves that balances underfitting and overfitting, leading to the best performance on unseen data. We use validation data to find the sweet spot. We train on training data and then we evaluate performance on the validation data by experimenting with different values for max leaf nodes and measuring the mean absolute error on the validation set. We can identify the number of leaves that gives us the best performance on unseen data. This helps us to choose a model that generalizes well and avoids the pitfalls of underfitting and overfitting. The goal is to minimize a validation error, indicating the best balance between model complexity and generalization. Understanding underfitting and overfitting is crucial for building effective machine learning models. It's a balancing act. We want a model that learns the important patterns without memorizing the noise. In the next lessons, we'll explore techniques for diagnosing underfitting and overfitting and strategies for finding that optimal balance. We've seen the trade-off with decision trees, deep trees overfit, shallow trees underfit. This lesson, Random Forest, introduces a powerful technique to address this, leading to much better predictions. A random forest uses many decision trees. Instead of one tree, it averages the predictions of each tree in the forest. In this ensemble approach generally leads to much better accuracy than a single tree. So you've got the foundational knowledge and some hands-on experience thanks to Kaggle. This week we're taking it to the next level. We're diving deeper into intermediate machine learning, focusing on feature engineering. Feature engineering is a crucial step in creating truly powerful and effective machine learning models. It's all about transforming the data you learned to manipulate with Pandas into even more meaningful inputs that can dramatically improve our model's performance. It's often said that feature engineering is more art than science, and it's where you can really make a big impact on your model's accuracy. Get ready to level up with ML game. On our Pandas journey on Kaggle, we started with absolute essential, creating, reading, and writing data. This foundation upon which everything else in Pandas is built. Without these skills, we can't effectively work with any real-world data. Mastering these basic operations, creating, reading, and writing, is absolutely essential. It's the foundation for everything else you'll do in Pandas. Without it, you can't even begin to explore, clean, or prepare your data for machine learning. The heart of Pandas is the data frame. Think of it as a table, rows and columns, just like a spreadsheet or SQL table. Data frames are incredibly versatile and are the primary way we organize and manipulate data in Pandas. Data frames are We learned how to create data frames from scratch, which is useful for small data sets and when we want to test something quickly. We also saw how to access and manipulate individual columns and rows within the data frames. Alongside data frames, we have series. A series is like a single column from a data frame. It's a one-dimensional labeled array capable of holding data of any type. integer, string, float, Python object, if you know programming. Understanding series is crucial because many Pandas operations work on a series basis. For example, you might perform calculations on a single column, a series within your data frame. While creating data frames and series manually is helping for learning, the real power of Pandas comes from its ability to read data from various sources. And the most common source you'll encounter is CSV files. We learned how to use pd-read CSV function to import data from CSV files directly into Pandas data frame. This is critical skill because almost all real-world datasets you'll work with will be in some kind of file format, and CSV is one of the most popular. We discussed how to specify file paths, handle different delimiters, and even how to deal with missing data during import process. Just as important as reading data is the ability to write data back out. We briefly touched on how to save our data frames back to CSV files using the toCSV function. This is essential for saving our work, sharing data, and preparing your data for other parts of your ML pipeline. Once we loaded our data into Pandas, the next crucial step is being able to access and manipulate specific parts of it. That's what this lesson, indexing, selecting, and assigning, is all about. It's like having a map to your data, knowing how to pinpoint exactly what you needed. Pandas provides powerful ways to select data using labels, the names of your rows and columns. The log indexer is our primary tool for this. It allows us to select rows and columns based on their labels. For example, we can use log to get all the data for a specific customer or extract a particular column like product price. This is incredibly useful when you are working with data where the labels have meaning. For instance, if the row labels are date or customer ID. Uh, it could be data, product price, and this will get the product price on that date. Sometimes we don't know the labels or we just want to select data based on its position in the data frame. That's where ilog comes in. Instead of labels, ilog uses integer positions to select rows and columns. For ilog 01 would get the element in the first row and second column because the numbers started from 0 and then 1, so ilog 01 would get the element in the first row and second column. This is useful when you are working with data where the order is important or when you need to select data based on its numerical index. For example, I log null 1 would get the element in the first row and second column, regardless of their labels. Mastering indexing, selecting, and assigning is fundamental for working effectively with pandas. It's how we navigate our data, extract the information we need, and prepare it for analysis and modeling. In the next lessons, we'll build on these skills and explore even more powerful data manipulation techniques. Now that we know how to access and select data, the next step is often to summarize it and extract meaningful insight. Summary functions and maps. This lesson equips us with tools to do just that. It's important getting a high level view of our data and efficiently transforming it when needed. Pandas gives us a rich set of summary functions that allows us to quickly calculate key statistics about our data. Functions like min gives us the average value of column, count tells us how many non-missing values are there, min and max reveal the extremes, and so on. These functions are incredibly useful for getting a sense of distribution of our data and identifying potential patterns and outliers. For a quick and comprehensive statistical function overview, the describe function is uh, valuable. It provides a summary of descriptive statistics for all numerical columns in your data frame, including count, mean, standard deviation, minimum, maximum, and quartiles. It's a fantastic way to get quick snapshot of distribution and central tendency of your numerical data. Sometimes we need to transform our data at the element level to apply a function to each individual value in the series. The map function is perfect for this. It allows us to apply a custom function or a predefined function to every element in a series. For example, we might want to convert all product names to lowercase or apply a discount percentage to each price. For more complex transformation that involve multiple columns or require more control, we can use the apply function. Apply can be used to apply a function to an entire row or column. This is particularly useful when we want to create a features based on calculations involving multiple existing features, or when we need to perform more sophisticated data cleaning or transformation steps. Summary functions and maps are essential tools for data exploration and preprocessing. They allow us to quickly understand our data, identify patterns, and transform it efficiently. In the next lessons, we'll continue to build on these skills and explore more advanced techniques for data analysis and manipulation. Often we want to analyze our data in the context of different categories. For example, we might want to know the total sales for each product, the average customer spending by region, or the number of orders placed for each year. This lesson, grouping and sorting, provides the tools to structure and organize our data to answer these kinds of questions. The group by function is incredibly powerful for analyzing data based on categories. It allows us to group our data frame by one or more columns. For example, we can group our data by product name to analyze sales performance for each individual product, or by year to understand trends over the time. Once we've grouped our data, we can then apply aggregation functions to extract meaningful insights. After grouping our data, we typically want to calculate some summary statistics for each group. This is where aggregation functions like sum, count, mean, median, max, and min come in. For instance, if we grouped our data by product name, we could use sum to calculate the sales for each product, count to count the number of orders for each product, or mean to find the average price. These aggregations provide valuable insights into the performance and characteristics of different groups. Once we've calculated our summaries, it's often helpful to sort the results to make them easier to interpret. The sort values function allows us to sort our data frame based on one or more columns. For example, we might want to sort our product sales from highest to lowest, or sort customers by their spending. Sorting makes it easier to identify trends, outliers, and top performance. The real power comes from contributing group by and sort values. We can group our data by a category, apply an aggregation function, and then sort the results to get a clear picture of the performance of different groups. For example, we could group our data by region, calculate the total sales for each region, and then sort the regions from highest to lowest sales. This gives us a powerful way to analyze and understand our data. Grouping and sorting are fundamental techniques for data analysis and reporting. They allow us to structure our data, extract meaningful insights, and present our findings clearly. These skills are essential for understanding patterns and trends in our data and for communicating those insights to others. In the next lessons, we'll explore even more advanced techniques for data manipulation and analysis. Before we can effectively analyze or model our data, we need to ensure its quality. Lesson data types and missing values focuses on two critical aspects of data quality: understanding the data types of our columns and handling missing values. These are essential steps in preparing our data for analysis and machine learning. Data quality is essential for analysis. We learned how to check data types using the types and convert them in with S type. Handling missing values is critical as they can affect results. We used isNull to identify them and fill na and or drop na to manage them effectively. Every in Panda data frame has a specific data type: index, float, string, boolean, date, time. Understanding these data types is crucial because it affects how we can manipulate and analyze the data. We learned how to use the data type attribute to check the data type of a column. We also saw how to convert data types using a type function. For example, we might need to convert a string call representing dates into date time type so we can perform time-based analysis or convert a column of floats to integers if the decimal precision is unnecessary and is taking up memory. Real-world data is rarely perfect and often contains missing values. These missing values can arise due to various reasons: incomplete records, data entry errors, or sensor malfunctions. It's crucial to identify these missing values because these can significantly affect our analysis and model performance. We learned how to use the isNull function to create the Boolean mask that indicates which value are missing true and which are present false. This allows us to see these gaps in data where they are. Once we identified missing values, we need to decide how to handle them. Pandas provides two main approaches: filling them in, imputation, or dropping the rows or column containing them. We explored the fill now function, which allows us to fill missing values with a specific value, like the mean, median, or constant, or using more sophisticated methods like forward fill or backward fill. We also learned about group now, which allows us to remove rows or columns that contain missing values. The choice between filling or dropping depends on the amount of missing data, the nature of your data, and the specific analysis you are performing. It's important to think carefully about how we handle missing data. Simply filling all missing values with a mean, for example, might not be the best approach if the data is not missing at random. Sometimes missingness itself can be informative. There are more advanced imputation techniques, but we'll cover those later. For now, it's important to be aware of the potential impact of the missing data and to choose an appropriate strategy. Understanding data types and handling missing values are essential steps in the data cleaning and preprocessing pipeline. Ensuring data quality is crucial for obtaining reliable insights and building robust machine learning models. In the next lessons, we'll explore even more advanced techniques for data preprocessing and feature engineering. Often data we need for analysis is spread across multiple files or comes from different sources. This final lesson in our Pandas series, Renaming and Combining, covers the essential techniques for bringing this data together and ensuring it's organized and consistent. Data often comes from different sources, requiring renaming and matching. We used rename to adjust column names for clarify. To combine data sets, we explored concat for staking data and mesh for integrating data based on common columns. The join function helps align data sets efficiently for analysis. In this course, we learned the fundamentals of Panda, including creating, reading, and writing data, selecting and modifying specific elements, summarizing and transforming data, grouping and sorting, handling missing values and data types, and renaming and combining data sets. Mastering these skills enables efficient data analysis and manipulation in Python. Sometimes columns names aren't very descriptive or consistent with our naming conventions. The rename functions allows us to easily exchange column names to make our data clearly easier to work with. It's important for code readability and for ensuring consistency when combining data from different sources. When we have data that's structured similarly but comes in multiple pieces, like data from different years, different regions, we can use the concat function to stack it together. Concat allows us to combine data frames vertically, adding rows, or horizontally, adding columns. This is useful for aggregation data from multiple files or combining data from different parts of a larger dataset. Often we need to combine data from different sources on a common column. For example, we might have customer information in one data frame and order information in another, and we want to combine them based on customer ID. The match function allows us to do this. It's like a database join. It combines data based on matching values in specified columns. This is a powerful way to integrate data from different sources and create a more complete view of our information. If it's very difficult to understand and you don't know programming, there is a course Introduction to Programming on the Kaggle.com site. You can read and learn about programming. The join function is another way to combine data. It's particularly useful and we want to align datasets based on their index tables. It's similar to match, but it uses the index as the key for combining data. This can be more efficient in certain situations, especially when working with time series data or data where the index has a special meaning. In this Pandas course, we covered a wide range of essential skills for data manipulation and analysis. We've learned how to create, read, and write data, select and modify specific elements, summarize and transform data, group and sort data, handle missing values and data types, and as we've just seen, rename and combine data sets. Mastering these skills empowers you to efficiently analyze and manipulate data in Python. which is crucial foundation for any machine learning project. Now that you have solid understanding in Pandas, we are ready to move on to the next stage, applying these data manipulation skills in the context of feature engineering. After finishing this course, you will get a certificate. You can find certificate in this page. So for this second week, you need to learn two Kaggle courses. Intro to Machine Learning. This course will introduce you to the ML concept and you will build your first models. You will learn about training data, validation, and key techniques like decision trees, and no prior experience is required. And also course on Pandas. It's a Python library. This course is important because it provides knowledge about data manipulation. You will practice the unloading, filtering, and transforming data using Pandas library. You will learn about fundamental skills and you will apply ML concepts there. So on this slide, you can learn the courses on machine learning. We recommend that you learn them. Also, there is a code lab. It will be helpful for you to do as a homework. It's not mandatory, but you will learn something new. Thank you all for participation. Please complete homework. This courses Introduction to Machine Learning and Pandas. You can ask us questions on Discord channel.